Hey, everybody. This is our last Science Saturday for the 21-22 school year. And we have got just kind of a wild card grab bag full of things for you this month. So what we're going to do is a series of videos for you to explain to you how the toys that you have work and some explanation about the science behind them. And then, you also have another kit of some sort in your bag that you want to complete on your own. Hopefully it's one that there are videos to go with it on the YouTube channel. And when you're finished, send a picture of your completed project to either Tammy Rifle or Aviva Yasgur, and they'll get that credit for your April Science Saturday. So we're going to do this in 4 different videos. The video that we're going to do now, the toy that we're going to talk about, is your centripetal spinner. And so that looks like this. And I want you to notice that as I kind of twirl that around in my hands, you're probably seeing some interesting pattern of color there. Most of the tapes on my spinner through the video look to you like they're clear and colorless. But you can see as I twirl it, there's a little bit of reflection there from something, maybe my pink sweater or maybe something else that we've got. And it is reflecting a little bit of color. If you look at your own, you should see a lot of different colors. You should see some pink and some blue and some green. You'll see some yellow. Maybe you call that color purple as you look at it. But I definitely see blue and pink and green and yellow. And again, maybe something that is you call purple, but to me looks like it's a darker pink. Okay, but this is what the centripetal spinner does. I'm going to give you a couple of tips just from experience. You'll notice that your spinner is attached at the top. The tapes are attached to the top of the tube or swizzle stick as you've got. And then the bottom plate is not attached. So that will go up and down on the tube. What we know from experience is that if you spin these too hard, they will get tangled up, and then you have to spend 5 or 10, maybe longer minutes getting those things untangled. You can do it, but if you'll just be real careful with it to begin with, that shouldn't happen to you, okay? So I'm actually going to take my spinner. I'm going to share my screen with you so that you all can see my document camera. And we're going to share the screen. And so now what you should be looking at instead of looking at me is the screen that I have in front of me, or the tabletop that I have in front of me. And what I've done is I've just taken 5 different colors of folders, and I have put those folders here underneath the document camera. Because what we want to do is kind of look at that film a little bit under each of those different colors or against each of those different colors of folder. So I'm going to turn my head now. You guys are going to look at the side of my head while we're talking about these spinners. So if you look at the spinner, when I lay it down here, put it against the red, some of the colors that we were seeing or that you're seeing on your own have kind of disappeared on this one. And I'm seeing a lot of yellow, and I'm seeing that really, really dark purple. But then I'm also looking at a lot of these tapes, and they look clear and colorless. And so when you look at it under that spinning, or under that as I'm turning it, you can see those different colors. And then as I increase that speed a little bit, those tapes begin to disappear. But I'm definitely seeing a lot of yellow there, and a whole lot of what looks like reflected light. And of course, I've got the overhead lights on in here, so you can imagine what that's doing with the reflection. You should also be noticing that as I twirl that back and forth, the shape of those tapes is beginning to change a little bit. And that's one of the things that we want to talk about. Okay. All right, I'm going to move the red folder out of the way. And now we've gone to yellow, or I'm sorry, orange folder. And now I'm seeing a lot of green and some really serious red with my with my tapes as I look at them in the screen. And when I look at them, just directly at the shape, I'm seeing some different colors as well. But what's really showing up against this orange is that red color and that green. I can see that green, and maybe every now and again I'm seeing a little bit of yellow. Okay. Move the orange away, and now I'm looking at that yellow folder, and now it looks like a Christmas tree, Christmas decoration, because I see almost exclusively red and green when I look at the screen. Again, when I look at this directly, I'm seeing some other colors too, but they're right at the very top and bottom of those tapes. But the major concentration that I'm seeing is the red and the green. Okay. I actually kind of like the way that one looks. So I'm going to pull the yellow folder out, and I've moved to the green. And now when you look at this, you may be seeing some purple. That's what I see. I can also see some blue, and that blue doesn't translate as well under the lights in the room and through the video. But I think if you look at your own spinner, if you can get it against a green background, you can kind of check on that. And again, also those bright flashes there are those my overhead lights shining down on those tapes. So the tape is just a Mylar tape. It's a plastic. It's kind of the same stuff that they use to make balloons. The shiny silver balloons, those are also Mylar. And these are actually, every single one of those pieces of tape is actually clear. But what happens with those tapes is that each of them has been coated with a really thin film of aluminum, the metal aluminum, okay? And that metal is kind of what gives it that reflective, shiny look. Because we all know that one of the big characteristics of metals is that they're shiny, they have luster. And on this blue, I'm seeing lots and lots of purple in the screen, but I'm seeing even more of that purple here under the lights. And if I turn it the right direction, on the back side of my tapes, I'm seeing some reflections of some green light as well. Okay. Well, here's what happens with that light while your colors are changing is that you've got two different layers on each of these tapes. You've got the plastic layer, which is clear plastic, and then you've got that coating of aluminum, which gives it that luster. And as light shines down on those tapes, it's either going to do one of two things. It's going to hit that aluminum coated surface, and some of that light is going to be absorbed, and the other light is going to be reflected, or it's going to hit the back side of those tapes, and you're going to get some absorption by the Mylar and some reflection by the Mylar. And so depending on what kind of background you've got, what kind of light absorption you've got and where it is, and the light absorption and reflection from both the aluminum and the Mylar are happening at the same time. And your eyes are interpreting that. And so based on what you are looking at that against and how you're moving it and what kind of light you have shining on it, you're going to get those different reflections of light back to you. And your eyes are going to interpret those depending upon which light is absorbed and which light is reflected. If you've had a chemistry class already, you've probably talked about absorption and emission of light and how that affects electrons in atoms. And so those electrons in that aluminum are behaving the same way. They absorb the right amount of light, and they kind of jump around in those aluminum atoms. And so there's the chemistry part of what's happening. And then I always forget about our color wheel and our absorption. When you absorb one light and reflect the others, those things are opposite one another on the color wheel. I don't see that working out exactly the way it's supposed to on here, but I think it's because my lights are so crazy. Okay. So pretty interesting color observations when you look at these things under the light and when you look at them against these backgrounds. Now I'm going to take one of my folders and bring it back. I'm going to bring that green one back. Just because if I don't have a folder here, the light hitting the ground surface of my desk reflects a whole lot. And so you can't see some of the things that maybe you want to see. And so what we really want to do is talk about why this thing is called the centripetal spinner. And, you know, everybody talks about the force called centrifugal force. And centrifugal force is actually not a real force. That's a term that has been created and developed, and people use that to think about as being a force that's the thing that causes you to move away from a circle. But that's really just a term called inertia. So we want to define centripetal force first. And centripetal force is a center-seeking force. That means if you're going around in a circle and you're moving in that circle, there is a force that as you move that pulls you towards the center of that circle. And that happens in a lot of different things. We'll talk about it with a couple of different examples. But one of my favorite examples of that is if you are riding the ride called the cyclotron at, if it's at an amusement park or it's at the county fair when you go to it. And if you'll think about what the cyclotron does, is you get in this big round, almost like a big drum. And it's got a floor on it, and they put people all the way around the walls of the cyclotron. And then they don't strap you in. All you do is stand up flat against that wall and put your hands up against the wall. And they start the engine and they start spinning the cyclotron. And if you've ever ridden the cyclotron, you know that it feels like you're being pushed against the wall, outside wall to your back of the cyclotron. And then they drop the floor out from underneath it. And so there you are spinning in that cyclotron with nothing underneath you. And why don't you fall out of the cyclotron? And the answer to that is the two forces. One of those forces is centripetal force, and the other one is inertia. Okay. So people use centrifugal, CENTRIFUGAL, to describe that inertia. But what it really is just an object's resistance to change in motion. So when you learn about Newton's 3 laws, you learn about the first law that says an object in motion stays in motion, and an object at rest stays at rest unless it's acted upon by an outside force. And so if you're riding on that cyclotron, the cyclotron is moving, but you're not attached to the cyclotron. You're not a part of the cyclotron. And so your body doesn't really want to spin. Instead, your body would like to, as soon as that cyclotron starts moving, it would like to continue in a straight line path from the point that you start moving. And so this is what you want to think about when you think about a cyclotron. So the cyclotron is a circle. Okay, and that's a pretty good circle just to draw freehand. And you're standing right here on the cyclotron. Okay, and the cyclotron is going to start spinning, and we're going to spin it this direction. All right. Well, you press up against the back of the cyclotron because you're not attached to it. And so when the cyclotron starts to move, you want to just keep moving in a straight line. And every point along the cyclotron, as it turns on that path, you want to continue to travel in a straight line. And because the cyclotron is turning and you want to continue to be in a straight line path, it feels like you are pressed up against the back of the cyclotron. And it feels like you're pressed up against the back of that cyclotron so strongly that there's no place for you to go. Now you think about it though, you know, if that cyclotron starts slowing down and they don't put that floor underneath you again, you know that what's going to happen is that force that you feel, it feels like you're pushing you against the wall, is going to feel like it goes away. And then you're going to feel like you're sliding down the wall and going to fall through the bottom of the cyclotron. And I think that's what makes that ride so scary, is not necessarily when it's spinning at high speed. It's when it starts to slow down and you're worried that you're going to fall through. Okay, so that's why they bring that floor back up. Because as the cyclotron slows down, your pathway still wants to be a straight line path, but the cyclotron's not moving around fast enough to keep you pressed up against that wall And so it feels like you're kind of sliding and slipping, okay? So the centripetal force is the force that pulls you right towards the middle, okay? It's the force that works this way, and that's caused by something that is spinning, okay? And then the force that people like to call centrifugal force is really just that term inertia. And inertia is equal to that resistance to change in motion. Okay. So anytime you're on a ride like that, and it feels like you're pressed up against that wall, that's that centripetal force and inertia acting on your body, because your body doesn't want to move with the cyclotron. Okay. Same thing happens when you're in a car. You think about a car driving down the road, and we're going to draw. Here's our road. And don't laugh at my car. When I taught physics, I always told kids that I was glad to be in physics because I could draw boxes and call them anything. But suppose that the car's driving down the road and it heads around this curve, and you're sitting in the passenger seat. Okay, here's you. And we'll put the steering wheel there. Somebody's driving that car down, and that car's going to start going around the curve. Okay. If you don't have your seatbelt on, think about which direction you're going to go when the car turns that curve, especially if that car takes that curve too fast. When that car is spinning or curving around that curve to the left, do you move in toward the driver, or do you move out towards the car door? Think about how many times you've moved over and had to readjust yourself in a car seat. Well, it's that centripetal force that's pulling that center-seeking force that's pulling the car in and acting on the car as it moves around the circle, but you're not attached to the car. So if the car started out going straight and it starts to make this turn, your body still wants to go in that straight direction, okay? So if the car moves around the curve and you're not moving with the car, then the car is actually moving itself into your way, and that's why it feels like you're hitting that car door. You put your seatbelt on, you don't feel as much of that because now you're strapped in and you're a part of the car, and the car, you're going to move with the car, and that's what's going to help you stay with the car. So we're kind of reducing the force of inertia there by putting that seatbelt on you and strapping you into the car, and keeping you as part of the motion of the car rather than your own motion yourself. Well, same thing. So suppose the car's now not going around a left curve, but it's going around a right curve. Here you are in your car. This is still the driver over here, and you're sitting in your passenger seat, and the car decides to go to the right. Well, do you turn into the wall, or not the wall, the car door? No, you turn over. And this time you lean over. It feels like your body's moving over towards the driver. Put that seatbelt on, though, and you become part of the motion of that car. And instead of going that straight line path and feeling like you're moving closer to the driver, you're now moving around the curve with the car. Well, the same thing is happening with our centripetal spinner, okay? So I pointed out to you earlier, let me switch my path a little bit, switch my folder a little bit so you're not seeing all that drawing. I pointed out to you earlier that you've got a fixed disc up here at the top. It is attached to the spinner, to the swivel stick, but your bottom disc is not. And so your bottom disc can slide up and down that spinner. Well, let's think about it. If I start spinning this thing, let me turn it on its side, and I start spinning this thing, my motion is going this way. And every time that my motion is going this way, this is not part of the This is not part of the automobile. It's not part of the thing that's spinning. This is. So this spins with this end spins with the swivel stick. And so this part of the tape up here at the top doesn't mind moving with the swivel stick. Down here at the bottom, though, the tape at the bottom is only attached to the disc, and the disc is not attached to the swivel stick. And so the swivel or the disc at the bottom doesn't want to move with the swivel stick. And so it's always lagging behind. And as it does that, the motion of the tape at the top moves with the swivel stick, but the motion of the tape at the bottom doesn't. And so that's what lets us create those really cool patterns. Okay. Now, if you're watching, first of all, it's probably making you dizzy if you're trying to watch that on the video, because you're losing sight of the tape as you do that. But if you'll hold that tape up in front of you, or not tape, if you'll hold that spinner up in front of you and spin it well enough, spin it fast enough, you see that that tape changes shape significantly. And I'm not just making it a fatter, rounder, I guess, if that's the term we want to use for it. We're not just making it fatter, we're actually changing the shape of it in the center. And so if you spin that fast enough and you watch it, you start to see a figure 8. And what's happening is that the bottom of the tape is lagging behind the motion of the top. And so it looks like your tape, can't do this like this. It looks like your tape is turning into a figure 8. It's not really, but it's the way your eyes are interpreting the motion of that tape. And that's what your eyes are telling you is happening. Okay. So we've got this center seeking force, and that's the centripetal force. We've got our not centrifugal force anymore, because that's not real. That's a non-physics term. We've got our inertia that says that bottom disc doesn't want to move. It's going to lag behind, like you in a car with the seatbelt or you on the cyclotron. And it's going to move more in a straight line and less in the circle that the swivel stick is spinning. And so it's going to cause that shape to change as you spin that back and forth. Now, like I said, you can spin that thing pretty fast. And when you do, you end up with that really nice figure 8. But now I have kind of tangled things up. If you tangle them up too bad, you're just going to have to take them apart. But you can spin it pretty fast, and it looks like it's going to tangle up, but it doesn't. And so it's a fun toy to play with. So just look at that reflection of light, and I'm looking at it. I'm seeing lots of orange on it with that green folder, but I'm also seeing these really great swirls, and you're just seeing a blur on that screen because it's moving so fast. So there's really very little way for me to slow it down. And I think you might be able to see I've got a pretty good sphere going on there as I spin that. Okay. So there's our centripetal spinner. And that's a whole lot of science for something that you thought was a little toy. So enjoy that. And if you're like me, you've got to. And believe it or not, I can sit for 30 minutes and do this and not do anything else. Okay? Centripetal force, inertia, and then reflection or absorption and reflection of light based on where that light is absorbed, which part of which layer, the aluminum or the mylar layer. You get reflection of light in a variety of colors. And then based on your surfaces that you're spinning it against, you're going to see the different colors of the rainbow. So we didn't talk about that, but remember that white light, the light that's coming out of the light fixture, the light from the sun, is all of the colors of the rainbow. And so you learned Roy G. Biv when you were younger: red, orange, yellow, green, blue, indigo, violet. And you're seeing all of those colors on your Mylar tape as we spin these. Okay, so there's toy number 1. Hope you learned a little something. And we will record this little video and post it on the YouTube page with the explanation, and then you can go out and impress everybody you know. Okay, stay tuned for another video.